In this section, we're continuing to look at functions. We're looking at different ways of representing these functions. We're looking at, given an equation and a set of numbers, so given an equation and a domain, we're going to be making a table and a graph based on that equation. We're also going to be looking at using equations to make some estimations and then testing it. So when you're given a table, or you're creating a table, we first need to take our equation and we're going to be filling in this chart. And it's going to be a lot more writing in this section, but I think you'll be just fine with the math. It'll be the writing that we really need to be concentrating on and actually doing it. So on your test, you're going to see a table similar to this already set up, and you're going to be filling in the table. And so the way we fill in this table is we say that our input is our x, and the inputs that they gave us 4 inputs. So they gave us 1, 2, 3, and 4. Those are the 4 inputs in our domain. Then we have our equation. Our equation is y equals x plus 3. And that's going to give us some outputs. So y is our output. We're going to start with that. We'll get to the last column in a minute. So the way we use the table is we say, well, we know that x is 1 because they told us x was 1. So let's see what happens. So we're going to fill in the equation. We're going to write that y equals 1 plus 3. So instead of y equals x plus 3, if x is 1, y equals 1 plus 3. We're going to substitute. We're going to get 4. We're going to do the same thing for the next one. We're going to get that y equals 2 plus 3. We're going to get 5. We're going to keep going. So go ahead, fill it in, fill the rest of the way. Y equals 3 plus 3, 6. Y equals 4 plus 3, 7. So we're really just filling in the data. We're given all this information. We just have to set up this table and figure out what outputs are we going to get based on the inputs that we're given. What's our range based on the domain? The last column is how we're going to use this table to help us graph the equation. So we're going to take an ordered pair. We're going to take our x, we're going to take our y, and we're going to create an ordered pair of our x's and y's, of our inputs and outputs. So the first one, x was 1 and y was 4. If x is 2, y is 5. If x is 3, y is 6. And if x is 4, y is 7. And that's how we can create a table and a set of ordered pairs based on our equation and based on our domain. That's it. That's how we fill in the table. That's how we fill in one of these big tables. And so what I'd like you to do is I'd like you to try this next one on your own. Pause it, fill in the table. I know some of you are going, oh, I know how to do this. Test yourself first. Don't just assume you can do it. Test yourself, pause it, fill in the table, look back at the one we just did. Remember the input goes here. The output, which is the range, goes in the third column there, and they're going to give you some values. So try this one on your own. I'm assuming you tried it. I'm assuming you filled in the table. Check your results and make sure you did it correctly. If you don't have those ordered pairs at the end, -1, -10, -2, -18, and so on, look at what you did wrong. Look at how you did that incorrectly, because 8 times -1 is -8. Minus 2 will give us -10. So if you multiplied your negatives incorrectly, or if you did -8 minus 2 is -6, you subtracted incorrectly. Make sure you're fixing those algebra mistakes, or those arithmetic mistakes, so you're not subtracting incorrectly. If it's 8 below and it gets 2 degrees colder, it's going to be 10 below. So -8 minus 2 is -10. So be careful of that arithmetic. Now that you've done that one, oops, excuse me, I skipped one, I think. Oh, no, I didn't. Never mind. Now you've done that one. We're gonna move on from that. We're gonna take those tables and we're gonna do some graphing with it. But before we can do the graph, we first need to make another table. So we're gonna make a table. There we go. And in this case, I have 1, 2, 3, 4 numbers in my domain. So I'm gonna need to make 5 rows. 1, 2, 3, 5. I've got my x numbers. I've got my y numbers. I've got my ordered pair. And now we have a couple choices. We can just fill in the equation as it is, and try and come up with a y that works. Or we can get y by itself first. And I think for this one, I'm just going to leave it alone. I think we're just going to put it in. You can certainly try and get y by itself, and that will be just fine. However, I'm gonna leave it as it is. So x minus 3y equals negative 6. I'm going to leave that the way it is. All right, so we know our x values, our domain values. We've got negative 3, 0, 3, and 6. So you can fill those in. Those are just given to me. I'm going to fill in the equation. So I know what x is. X is negative 3. Minus 3y equals negative 6. 0 minus 3y equals negative 6. 3 minus 3y equals negative 6. 6 minus 3y. So the way I've chosen to do it, and this is maybe not the best way, but it's the way I've chosen to do it, is I've got this filled in. I got to figure out what y is to make this work. So let's see, if y was 1, negative 3 minus 3 would give me negative 6. So if y was 1, negative 3 times 1 would be negative 3. And negative 3 minus negative 3 would be negative 6. So I got that y was equal to 1. And so that worked out well for me. Let's try the next one. So 0 minus something equals negative 6. Well, I know that 0 minus 6 would be negative 6. So that means that y would have to be 2. Because 3 times 2 is 6, and 0 minus 6 is going to give me negative 6. So y has to be 2 in this one. And so you see that you could certainly solve for y. You could subtract x from both sides. You have negative 3y equals negative 6 minus x. And you can get y by itself, and that would work. Or you can kind of work it out as it sits. 3 minus 3 is not going to give me negative 6. 3 minus 9 is going to give me negative 6, which means this is going to have to be 3. 3 minus 3 times 3 equals negative 6. And I bet the next one's 4. Let's test it. 3 times 4 is 12. 6 minus 12. Yep, 6 minus 12 is negative 6, so it's 4. So there are multiple ways to do these problems. You can either work it out and solve for y, like I started to do up here, and then fill it in, or you can do some working out in your head. So I've got then my ordered pair, negative 3, 1, 0, 2, 3, 3, and 6, 4. And I'm going to fill that in on my graph now. So I have these ordered pairs. Now I need to graph those ordered pairs. So I start at the origin. I do my x's first. Remember, x-axis, y-axis. I go negative 3, 1, 0, 2, 3, 3, 1, 2, 3, and 6, 4. Now this one's going to go off my graph just a little bit. In fact, anything are 1, 2, 3, 4, 5, just a little bit more. So I'm just going to extend my graph. And so there's 6 right there. So 6 and 1, 2, 3, 4. So right there. Go. Now, at this point, I do have an equation that goes with this. So I know that everything in between these points will work because I have an equation. So even though every point is not in the table, I have an equation that goes with it. And so I can fill in the graph and connect those dots. So that's how we can use an equation to make a table and a graph. Give this one a try on your own. You do need to make a table, yes. You do need to graph it, yes. I'm assuming you paused it. I'm assuming you tried it on your own. I'm going to reveal the answer here. Yep, it's a lot of work, but look at your results, especially for the ordered pair. Negative 2, 1, negative 1, negative 2, 0, negative 3, 1, negative 2, and 2, 1. If you did not have those results, remember that negative 2 squared is not negative 4. Negative 2 times negative 2, positive 4. And so if you got negative 7 for your first result there, it's the arithmetic, not the new material, but that arithmetic, and really being careful with your multiplying and your exponents. That negative 2 squared is a positive 4, minus 3 is 1. Negative 1 squared is a positive 1, minus 3 is negative 2. It does end up being kind of a U shape. If you didn't know it was going to be a U shape and you made it more of a V or something, you can just fix that. It would end up being a U shape. Anytime you see an x squared, excuse me, it ends up being a U shape. You'll spend more time with that in the second half of the chapter, or not chapter, sorry, second half of the book, chapter 8 or 9, I think, is when you deal a lot with squared, called quadratics. And this one, again, please do pause it. Practice making the table. Practice filling it in. Be really careful with your arithmetic. Make sure that you're dealing with those vertical lines correctly. I'm not going to say what they are. We'll talk about it in class. But make sure you're dealing with those vertical bars correctly and then graphing it from there. I'm assuming you paused it. I'm assuming you tried it on your own. These are the results. Maybe. Sorry, waiting for the computer. There we go. Here are the results. Let's see if I can get that. There we go. So it should be negative 2, 4, negative 1, 3, 0, 2, 1, 3, and 2, 4. Again, those vertical bars, the absolute value bars, those absolute value bars always create a positive result because the absolute value of negative 2 is 2, plus 2 is 4. Absolute value of negative 1 is 1, plus 2 is 3, and so on. And so when you're doing these problems, be very careful with your absolute values, your exponents. And this one does end up being a V. Absolute values are going to give us a V shape for that. All right, last little bit. How am I doing on time? Ooh, a little bit over 10 minutes. Last little bit here. We're going to use the graph of the function to find the value of f of x when x is negative 4. The idea here is we know what x is. Ooh, here we go again. We know what x is. X is negative 4. And so when we look at, on the graph, x is negative 4, what do we get from the graph? Looks like 6. So when x is negative 4, f of x is 6. And that's it. I mean, that's how you find the answer. So when it says use the graph to find the value, we just look at the graph and say, well, x is negative 4. There we go, negative 4. Where does it meet with the graph? Right here. That's where it meets the red line. And what value is that? 6. So x of negative 4, 6. And we can check that result by just substituting and saying, well, f of negative 4, negative 1/2 times negative 4 plus 4. We can substitute it back into this original function here and say, well, negative 1/2 of negative 4 is 2 plus 4 is 6. So sure enough, f of negative 4 does work out to be 6. And the last little bit here, that was the bell. Use the graph to find the value of x when f of x is 3. So remember that f of x is a lot like y. It's like saying y equals 3. So if y is 3, we get that x must be 3. So f of 3 equals 3. And you can check that. And you could say, well, I think f of 3 equals 3, so let's substitute into the original function here 1/3 of 3 plus 2. Well, 1/3 of 3 is 1, plus 2 does, in fact, equal 3. So it does work. And that's how we do those problems.